Hello everybody. Welcome to Bodha Academy. In this video, I am going to discuss problems which were asked in AIEEE and JEE Mains related to bulbs and power concept. First problem, a 220 volt 1000 watt bulb is connected across 110 volt main supply. Find power consumed. So here in the problem, you can observe that voltage of bulb and applied voltage are different. We are supposed to find power consumed. Let us draw the circuit. So voltage of the bulb, I'll denote it as V0, which is equal to 220 volts. Power of the bulb, I'll denote as P0, which is equal to 1000 watt. Resistance of the bulb, I'll denote as RB. Applied voltage, let me denote as VA, is equals to 110 volt. Now resistance of the bulb is given as resistance of the bulb is equals to V0 square divided by power P0, V0 square by P0. So that's equals to V0 is nothing but 220. So 220 V0 square means 220 into 220 divided by P0 is nothing but 1000. So this on simplification we'll be getting as 48.4 ohms. We'll get as 48.4 ohms. Okay. Now we want to find power consumed. So power consumed is given as P is equals to applied voltage square divided by resistance of the bulb. Applied voltage square divided by resistance of the bulb. So that's equals to applied voltage is nothing but 110. So we'll get 110 into 110 divided by resistance of bulb we are determined as 48.4 ohms. So this on simplification we'll getting as 250 watt. So this is a simple problem asked in AIEEE 2003. Okay, let us proceed for next problem. So in this problem, supply voltage is given as 120 volt. Supply voltage is 120 volt. Resistance of lead wires is 6 ohm. 60 watt bulb is switched on. What is decrease in voltage across the bulb when 240 watt heater is connected to it, parallel to the bulb? Okay. So initially bulb alone is present in the circuit. Then a 240 watt heater is connected parallel to the bulb. Then what is the decreasing voltage across the bulb that we are supposed to find out? Okay. So let us draw the circuit. So first part. So power of the bulb I'll denote as P0. Resistance of the bulb I'll denote as RB. So first I'll determine the resistance value of the bulb. So resistance of the bulb is equals to V square by P0. Here value of V is not given. Voltage across bulb is not given. By default, we'll assume that voltage across bulb and applied voltage are one and the same. So this voltage is nothing but 120. Voltage square means 120 into 120 by power is 60. So this on simplification will get resistance of bulb as 240 ohms. We'll get resistance of bulb as 240 ohms. Okay. Then we'll find out what is current in the circuit. So current, let me denote as I1. Current in the circuit denote as I1. It will be flowing like this. So this current can be determined by using Ohm's law. So I1 is equals to V is equals to IR is Ohm's law. So I is 1 is equals to V by R effective. Effective resistance, let me call it as R effective 1. So just I'm applying Ohm's law here. So that's equals to V is nothing but 120 volt and effective resistance. Here two resistors are connected in series. One is resistance of bulb RB, other one is resistance of wires small r. So in series combination, the effective resistance is given as R1 plus R2 formula. That is here it is RB plus R. So that's equals to 120 divided by RB is nothing but 240. Small r is nothing but 6. So we'll get this as 120 by 246. 120 by 246. So we'll keep as it is. Next, we want to find voltage across bulb. So voltage across bulb, I'll call it as V1. So I can find V1 is equals to, again I'll apply Ohm's law, I1 into resistance of bulb RB. I'm simply applying Ohm's law. So that's equals to I1 is nothing but 120 by 246 into resistance of bulb we are determined as 240 ohms. So into 240. So this on simplification we'll be getting as 117.7 volt. 117.7 volts. Okay. Now in the second part we'll connect a heater parallel to the bulb and see what happens. So second part, heater is connected parallel to the bulb. So resistance of bulb just now we had determined as 240 ohms. We had determined in previous page. So here we can observe it. So resistance of heater, let me call it as RH. Now we are supposed to determine resistance of heater. Resistance of heater is not given. So resistance of heater, I can write it as RH is equals to V square by power of heater. So power of heater in the problem it is given as 240 watt heater, 240 watt here. So power is nothing but 240 watt. So this I can write it as RH is equals to V. Here also voltage across heater is not given. By default we will be assuming that heater is also having voltage rating similar to that of applied voltage. So here I will be writing 120 into 120 divided by power of heater is 240. So this on simplification we'll be getting 60 ohms. We'll be getting 60 ohms. Okay, so we are determining resistance of the heater. Okay, now we'll find current in the circuit. So current, this current let me call it as I2. So current will be flowing in this direction. So this I2 we will find out by applying Ohm's law. So I2 is equals to V by R effective. V by R effective. So that's equals to R effective is nothing but here two resistors are connected in parallel. So resistance of bulb RB and resistance of heater RH are connected in parallel. So in parallel combination, effective resistance is given as RB into RH divided by RB plus RH. Now this entire thing is connected in series with the lead wires resistance small r. So in series combination effective resistance is R1 plus R2. R1 means I'll take this entire resistance, I'll take it as R1 and this resistance I'll take it as R2. So effective resistance here is nothing but R1 plus R2 means here this parallel combination of this resistance is R1 and this resistance I'll take it as R2. So this is the resistance we'll be getting. So substitute the values and simplify. So this we can write it as applied voltage is nothing but 120 divided by resistance of the bulb 240, resistance of heater is nothing but 60 ohms. We got it as 60 ohms. So into 60 divided by 240 plus 60, whole thing plus smaller value is 6. Smaller value is 6. So this on simplification, this entire thing we are supposed to simplify. So this on simplification, we will get the current value as 60 by 27 ampere. 60 by 27 ampere. Okay. Now we want voltage across bulb in this case. So again, I'll apply Ohm's law. Voltage is equals to I2 into R effective. So voltage across bulb. Here bulb and heater are connected in parallel. In parallel combination, potential difference is same. So voltage across bulb and voltage across heater will be one and the same. So I can write this voltage across bulb is equals to I2 into R effective 2. R effective 3. Let me call this as 3. Let me take it as 2. So that's equals to, I can call it I2 value, I2 into R effective. This bulb and heater in parallel combination. So effective resistance is nothing but RB into RH divided by RB plus RH. Substitute the values. I2 value is nothing but 60 by 27 and RB, RH values are nothing but RB is nothing but 240, RH value is 60 divided by 240 plus 60. So this on simplification we'll be getting as 106.66 volts. 106.66 volt. So with the heater, the voltage across bulb, heater in parallel, the voltage across bulb is 106.66 volt. The question is, what is decrease in voltage? So that we'll find out. So last part. Decrease in voltage is equals to initial voltage minus final voltage. So initial voltage of the bulb is 117.7. We got it as 117, observe here, 117.7 volts. And final voltage, we got it as 106.66 minus 106.66, 106.66. So this on simplification, we'll get it as 10.4 volts, 10.4 volts. Okay. So this is the final answer you'll be getting. Decrease in the voltage is nothing but 10.4 volts. Hope we are able to understand the problem clearly. Okay. So we'll meet in the next video. Thank you.